So we're looking at notes 12.7, which is theoretical and experimental probability. Our essential question is, can I find the theoretical and experimental probability of an event? I know there's a lot of vocab here, and I want to make sure that you get it all written down. So if you need to pause the video, please do so. Okay. Make sure it's written down, and I'm going to talk about each of these. So let's start with probability. What is it? It's the likeliness an event will occur. And I want us to know that we can write the probability either as a decimal, a fraction, or a percent. So the likeliness something will occur, the event will occur. So let's talk about what the event is. Okay, the event is any outcome or groups of outcomes. And so then, of course, that leads us on to what is outcome? Well, an outcome is the result of a single trial. Okay. So the very last one we want to talk about here would be sample space, and what sample space is, and it's all those possible outcomes. Okay. I know a lot of that might be confusing. The biggest thing we really want to focus on here is the probability, what it means, and how we find it. So when we think of theoretical probability, we're thinking about what should happen. So what should happen? Let's think about flipping a coin. If we had a coin, let's say we had a quarter, we know that one side of that quarter is tails and one side of that quarter is heads. So what should happen is 50% of the time, 1/2, because 1/2 of the coin is actually tails. So 50% of the time, the coin should land on tails. And the other half, or 50% of the time, the coin should land on heads. But here's the deal. That's theoretical, what should happen. Unfortunately, when we actually do the experiment, which is where we get into experimental probability, it's what actually does happen. So the experimental probability is literally would be taking a coin and flipping the coin. Let's say we flip the coin 100 times. Let's say that heads was 41 out of 100 and tails was 59 out of 100. Experimental probability is what actually happened. So we flipped the coin 100 times, and what we got was 41% of the time it was heads, and 59% of the time it was tails. So that's kind of the difference between theoretical and experimental. Theoretical is what should happen. Experimental is what does happen when you actually do the experiment. Very beginning, please make sure you had it all written down. That's it. So I went a little too fast there. There we go. We're going to jump into finding actual theoretical probability. Okay. So when you see the P, that stands for probability, and then in the parentheses it'll say probability and then the event, what they want the probability to be of. So if we look at this one, let's look at our spinner here. What would be the probability of landing on an even number? Well, how many are even? We've got 2, 4, 6, and 8. So that would be 4. And how many total options are there? How many total possible outcomes are there? Well, there are 8 spaces. So 50% of the time, 4 out of 8, or 1/2, 50% of the time we should land on an even number. Okay. What if we said, what is the probability of landing on a prime number? Well, a prime number is divisible by 1 in itself, and 2 is a prime number, and 3 is a prime number, 5 is a prime number, and 7 is a prime number. So actually, we also have 4/8 for this one as well. Okay, let's think about a dice. We know that on a dice, we have the numbers 1, 2, 3, 4, 5, and 6. Okay, let's think about what would be the probability of rolling 3 or greater. Well, what numbers are 3 or greater? How many are there? How many favorable outcomes? There are 4. How many total different outcomes can we get? Possible outcomes? There are 6 possible outcomes. So this would be 4/6. So finding probability and finding the theoretical probability. The experimental probability, we actually do the experiment. Let's go on. And a lot of vocab. Look at our very last thing here, which is talking about the odds, okay, which is describing the likelihood of an event as a ratio comparing the number of favorable and unfavorable outcomes. So the odds in favor. So let's just talk about what would be the favorable outcomes of landing on a number greater than or equal to 6. So greater or equal to 6. Well, 6 is greater than or equal to 6, 7, and 8. So these would be our favorable outcomes. So the odds in favor, how many total numbers do we have in favor? We have 3. And how many numbers are not in favor, or how many numbers we should say are less than 6? Well, we have 1 through 5. So this would be 3/5. That would be the odds in favor. You state the favorable outcomes in the top of your ratio because we want in favor, and then your unfavorable outcomes in the bottom. And so that's for in favor. Let's talk about the odds against, meaning unfavorable. If we take this exact same situation, if we want to know the odds against this, it would have been our 5 in the numerator divided by our favorable outcomes, which would have been the 6, the 7, and the 8, 3 different numbers. So we've talked about probability, finding theoretical and experimental. We've also talked about our odds in favor and our